Good day, guys. Welcome to today's lesson on STAAD.Pro Connect Edition. In today's lesson, we are going to be designing this simple frame. Now, you can see our stanchion. The height of the stanchion is 3 meters. Then the span of the beam. Let me draw the span. So let's go to utilities, node to node tools, and node to node distance. So from this node to this node is 4 meters, from this node to this node is 6 meters, and this node to this node is 6 meters. Whilst this node to this node is 3.9, this is also 3.9. Okay, so once you measure that, then you can also count the numbers or secondary beams we have. So from this point to this point is a staircase which is 2 meters, and this point to this point is also 2 meters. Now what we've done is we've assigned a simple property IP 330 for this beam along the span, IP 180 for all the beams parallel to this side, IP 200 for the stanchion, IP 240 for these beams, these primary beams. Then this is no longer there, so let me delete this, which we are not using. Then IP80, we are not using that. Okay, now the next thing is the material. You can see everything is made of steel. Okay, there are specifications. So at the start we released 99% of the moment, whilst at the end we released 99% of the moment. So let's go to support. You can see at the support we fixed it. Now we fixed the support because we want structural stability. So if we pin the support, the frame is going to sway seriously, it's going to deflect seriously because there are no bracing for lateral loading. So let's go to the load. So since this is just a one-story building, what we just have is just the dead and the live. So for the dead load, we have the self weight which is assigned to it. Let me remove the distance. Okay, remove not to know distance. Okay, so we have applied the self weight. Now we've applied 2.17. So the one that is highlighted blue is from here to here. So let's double click our loading to see it. You can see the minimum bridges are 3, then the maximum is anything above 3 or 3 on the dot. So I left it as 3. Then the X range, that is from here to here, I left it as 0. But the Z range from this point to this point is 8 meters. So that's why I did 0 to 8. The pressure, is minus 2.17. So this value was got from Comfort 60. So the weight of the slab on this is 2.17. That's the wet weight of it. Okay, so 2.17 kilo pascal. That's what we have. So the other one too is 2.17, but it's ranging from here to here, whilst this is only ranging along this axis. So you can see I played with my X also at that point there too. Okay, so same thing with the live load. The live load of, so let's double click it. You can see the live load of minus 5.5. So what really happened was I used the live load of 4. Then for partition, I used 1.5. So 4 plus 1.5 will give me 5.5. So that's what I have. Now let's go to the analysis. I've created a command to perform the analysis. Then we'll go to design. So let's go to design. Let's define some parameters, basic parameters. So for example, I'm going to be using C1. So for my stanchion, since my stanchion is pinned at the top and fixed at the bottom, so it means there'll be bullet at the bottom. So I'll use 1.77. So that is it. But the default value that was there, which is, let's go back, the 1.132 is for simply supported beams. So I don't need, since my beams are simply supported, I don't need to change that. Next thing I need to do is deflection, but it's on the default of 360, so I don't need to change it, except I want to change it to 500, and I will change my DFF and DJ1, DJ2. Dmax, I'm not selected, so I'll leave this. Dmin, I'm not doing anything. So my ETFB, so you can see the distance between the torsion, adjacent torsional restraints. So it's for tapered members, so I'm not going to use this. Okay, so my GMO, GM1 and GM2, once I change my national annex, it changes automatically. So you can see my GMO is 1, GM1 is, this is gamma M1 is 1, whilst my gamma M2 is 1.25. But in the UK national annex, gamma M2 is 1.1, yes, 1.1 or 1.15 if I remember. So you can go to national annex and choose UK. So automatically you will see it will change once you check the calculation sheet. Add. Then what else again? The SGR I want to use 275. So add. Okay. Then track the type of calculation. I want output detailed results. Okay. Add. Then now, since my secondary beams are fully restrained, I will come to UNL and make this 0. Add. Okay. Select. So I'm going to select all my secondary beams, that is beams along the X direction. So select beams parallel to the X direction, assign to selected beam. So it means they are fully restrained. So assign to view, assign to view, add, select all the stanchions, beams parallel to Y, assign to selected beams. Okay, so the next thing I need to do now is to check code. Okay, add those. Then once I'm done with assign to view, okay, so once I'm done with that, I will just run my analysis. Okay, so let's run the analysis. So it might take a little while for it to run. So we have 0 error, 0 one note. So let's go to post processing. Okay, so after doing that, let's look at the utilization ratio. So I can click it. So you can see all members are green. So utilization ratio. Okay, so you can see the actual ratio. So let's see the one that takes the most value. So IPU 240 is using 94.2% of its capacity. So let me select that particular beam. So selecting that beam, let's double click it and let's see what it is about. Now you can see it has an MZ moment of 94 and the MZ capacity is what, 100. So approximately that, but without adding the moments in along about the minor axis. So you can see, but dividing this by this will give us something like this. So look at this clause in the code you get. Okay, so we've done that already. Now we are done with the first part of the video. Let's change to the second part of the video without assigning any design parameter. Let's see what it will give us. Okay, so let's go to the command file and let's just delete all the let's delete all the parameters. So I'm not using C1, C2. The only thing I'm using is the national annex. So I'll delete this, delete SGR trap 2 UNL. Yes. Okay, so let's see the effective results. It might not be that much. Okay, so we have 2 errors. Let's go back to this. Okay, design. Okay, code. So it's changing the code automatically. There's a mistake. The code is supposed to be the Eurocode which we are using. Okay, sorry, let me delete this. Delete. Okay, so I'll change this to Eurocode this. Define my parameter. So the only parameter in this case I'm defining is the national annex. Okay, sorry, it's supposed to be UK. Add what else again? The SGR grade of steel I'll be adding is this 275. Add. Then the UNL, let me track 2 because I need a detailed output. Okay, add. The UNL, add also, close. So what I need to do is delete this one, delete. Okay, then SGR assign to view, assign to view, the UNO. So I'll select parallel to the X direction. Okay, assign to selected beams, assign, check code, and check that, add, close, assign to view. Okay, so let's run the analysis. So we have some warnings. So let's see what our warnings are. Let's see what they are. So it will be something we can clear. So you can see the axial compressive stress exceed the Euler stress for member 14 and 16. So let's select. We can go back and check what member 14 and 16 are later. But let's just see utilization ratio without others. So we can still see the past, but it's giving us a warning which we need to add up. Okay. So thank you for watching today's video. If you have any question, you can drop it in the comment section. Thank you very much.